Hello my dear students, welcome back to another video lesson. We were discussing about current electricity in last two parts. We are continuing the discussion. Here also more 2 mark and 3 mark questions we will discuss in this video lesson. Hope you prepared based on previous lessons. Now keep moving on. Do your best preparation ever. Wish you all the best for the upcoming exams. Let's go through the questions. Here's the question number 1. Write the relation between resistance R and electrical resistivity ρ of the material of conductor in the shape of cylinder of length L and area of cross-section A. Hence, derive the SI unit of electrical resistivity. One part. Then I have second. 2-3 parts questions are there. It's 5 mark. So second part. The resistance of a metal of length 3 meter is 60 ohm. If the area of cross-section of the wire is 4 into 10 raised to minus 7 meters square, calculate the electrical resistivity of the wire. So from the first equation, you have to find the resistivity by using that. Third part, state how would electrical resistivity be affected if the wire is stretched so that its length is doubled. Justify your answer. So it's a 5 mark question. In this video lesson, 3 mark and 5 mark, most of the questions will come to you. Okay, let's see the first part. Write the relationship between resistance R and electrical resistivity ρ of the material of the conductor. You know the relation. The resistance R is directly proportional to length of the cylindrical wire and it is inversely proportional to area of cross-section of the wire. Length and inversely proportional to area of cross-section. From this relationship, if this proportionality you convert to an equation, then we get R is equal to a constant ρ into L by A, where this ρ is known as resistivity of the material. Resistivity. So this is the relation between R and ρ. So resistance is the property of a material to oppose or to apply a hindrance to the flow of current through it. And resistivity, it is the basic nature of the material of a wire to resist the flow of current through it if wire have unit cross-sectional area and unit length. So resistivity is resistance itself, but the wire of unit cross-sectional area and unit length. Per unit volume also we could call it as. That's the just difference between resistivity and resistance only. So here in the first part is asking just to write the relation between resistance and resistivity in terms of length and area of cross-section. And one more thing they are asking, derive the SI unit of electrical resistivity. So for that you have to substitute all the resistivity equation. So here ρ will be equal to, you rearrange this equation, R into A divided by L we have. Ρ is equal to R into resistance into area of cross-section divided by length. Here if you substitute the units, we have for resistance we have the unit ohm into, for area of cross-section we have the unit meter squared divided by, for length we have the unit meter. So 1 meter and this meter cancels, remaining is ohm meter. The SI unit of resistivity is ohm meter. Resistance have the unit ohm and resistivity have the unit ohm meter. You got it? That's the first part. Now come to the second part. It's a numerical session. The resistance of a material of length 3 meter, L is given and resistance is given 60 ohm. And area of cross-section is also given 4 into 10 raised to minus 7 meters square. You have to find the electrical resistivity. So ρ you have to find out. What is the equation? R into A divided by L. So if you do it, it will be ρ is equal to R into A divided by L. My dear students, whenever you solve a numerical question, you have to write the expression clearly. You have to record the data in SI system, then substitute. For that much part, almost half of the numerical mark you will get it. Suppose it's a 3 mark question, then there itself you will get 1 or 1.5 marks by posting all data in SI system and recording equally. Then the last calculation comes. So expression should be clear. Here, this given, resistance R is given, length is given, area of cross-section given. We have resistance is 60 ohm, length is 3 meter. So 60 ohm, length is 3 meters. And area of cross-section is given 4 into 10 raised to minus 7 meters square. So 4 into 10 raised to 7 meters square, minus 7 meters square. So ohm, meter and meter square is all are in SI system only. So no need to convert again. You have to substitute clearly, properly. So here rho equal to R into R means 60 into A, area of cross section, 4 into 10 raised to minus 7 divided by L is the length, that is 3 meters. So if you solve it, 60 and 3 you can cancel, that's 20. 20 into 4, that is 80. So that is 80 into 10 raised to minus 7 ohm meter, or this you can write 8 into 10 raised to minus 6 ohm meters. That is the resistivity, electrical resistivity of this conductor, the material. Resistivity depends only on material and temperature. That's another concept. Now check the third part. So here we calculated the electrical resistivity. All are given in SI system, so no need to convert there. Here, state how would this electrical resistivity be affected if the wire mentioned in the part 2, this part, is stretched so that its length is doubled. So take utmost care, they are asking for electrical resistivity, how it is changing. Electrical resistivity, how it is changing is the question. See, resistivity is the basic properties of the material of the wire. Unless and until you change the material of the wire, like copper wire is mixed with some aluminum, or copper is mixed with some iron, or nickel, like that mixture is made, then resistivity will change. Otherwise, a wire being copper as it is, its resistivity will be constant at constant temperature. Now, if you heat up the wire, metal is getting heated, then resistivity changes itself. For conductors, the resistivity increases with the temperature. And for semiconductors like silicon and germanium, the resistivity decreases with the temperature. Alloys is very least depend only. So metals, when they heated, the resistivity also increases. So only two factors resistivity depends. So here is given, the wire is stretched to length double. So only length change will be there and cross-sectional area also change will be there. So resistance may change, but there is no change in resistivity because resistivity depends only on length, area of cross-section, temperature, nature of material. Out of these four factors, only two the resistivity depends. Which are the two? Nature of the material and temperature. If you say about resistance, electrical resistance, that depends upon all the four factors. You must study it. Four factors: material, temperature, length, area of cross-section. Out of these four, only two resistivity depends. All the four resistance depends. Hope you got it? So justification is that it depends only on two. It's property of the material. Okay? Let's see the next question. State whether the currents and potential difference in all the bulbs will be same or different. Will be same or different when in a circuit 3 bulbs off. So 3 bulbs we have, they are connected in different ways. Okay. So part A, in this one let's say whether current will be same or different, or potential difference will be same or different. You know, when resistors or devices are connected in series, same current pass through all the resistors, but the potential difference will be different. The voltage across them will be different. In parallel combination, voltage across each devices will be same because all of them are connected between 2 common points only. So their voltage will be same, but current will be different. That ideas you have to use here also. So first part, same wattage are connected in series. In series they are connected. So same current will be there. Current will be same. That's understood. No doubt at all. Whatever the resistance, whatever the power change, nothing else. If in series, then same current have to pass through it. Because after passing through one device, there's only one way in front of that current to pass through it. So only the same current have to pass through it. So current will be same. Now, in series they are connected, hence the potential difference or the voltage will be different. So same current is there and different voltage will be there. Hope you got it. In series combination that happens. So they have mentioned the same wattage. So don't get confused that same wattage means same power it is. So though power is same, still in series the accumulation of voltage happens in each point like. So voltage will be different there. Okay, unless they are of identical material. Identical means same material is made up of each. Then potential difference may be same. We can keep it by calculating the values. Hope you got it? Next one. B. Same wattage are connected in parallel. So same wattage are there. In parallel they are connected. In parallel the voltage will be same. All of them. And current will be of course will be different. So here same voltage and different current. Now see, different wattage are connected in series, different powers, but in series they are connected. In series, one rule is confirmed, current will be same. So there are also same current is there, but the potential difference or the voltage is different. Now the fourth part, different wattage are connected in parallel. So in parallel, what are the different resistors are there? What may be the values change, but in parallel the voltage will be same. So same voltage will be, and a different current will pass through it. So it's according to the current, the connection only it will be. You got it. See the part 2. Two identical resistors of 24 ohm each are connected to a battery of 6 volt. So we have two resistors here, R1 and R2, both are equal how much? 24 ohm. And one battery is there of voltage 6 volt. Calculate the ratio of power consumed by the resulting combinations with minimum resistance and maximum resistance. So in resistance combinations, the part 2 video lessons we have done already. Means that one, in series combination we get maximum resistance, and in parallel combination we get minimum resistance. So here part A is minimum resistance. So these two resistors are connected in parallel. So first part we have to connect them in parallel. So here in the second question, part A, so parallel connection is there. Then only they give minimum resistance. So their RP will be, both are same values, then you might have the shortcut. 1 by RP is equal to 1 by R1 plus 1 by R2 is the original equation. If R1 and R2 both are equal, then you can say RP will be equal to R by 2. There are two resistors. So R is 24, 24 by 2 is 12 ohm is the net resistance RP. And the power, what is power will be? V squared by R, because V is given 6 volt. So V squared by R, you can use it. Let it be there. RP we find. Now ratio of the power is the question. So direct ratios you can do it. Instead of each one, what is the power in order to calculate? Direct ratio in the calculation you can use it. So B part, maximum resistance. Maximum resistance means they are connected in series. So this is series combination. So there RS is equal to R1 plus R2. So it will be 24 plus 24. That is how much? 48 ohm. So that is series combination. Now you have to find the ratio of the power. So ratio of the power is given by in minimum to maximum is asking. So minimum power means power in parallel circuit divided by power in series circuit. So in both the 6 volt battery is there. So you can use the equation for power as V squared divided by RP divided by V squared divided by RS. This will be the ratio. We have an equation power P is equal to V into I or I square into R, or V square by R. These three equations we have. What are the equations? Power P is equal to V into I. Power P is equal to I square into R. Power P is equal to V square by R. Out of these three, if same current is passing through it, you can use the second equation. If same voltage is there, you can use the third equations. You got it? So here, first case here, V square, V is same in both cases, 6 volt. So it will be V square by RP by V square by RS is there. So that is RS by RP. Reciprocal, you have to multiply with. So RS by V square cancels, will be equal to. Now we have RS means in series combination, how much is the resistance? 48 ohm. In parallel combination, what is the resistance? 12 ohm. So the answer is 48 by 12, that is 4 by 1. So the ratio is 4:1 is the answer. So minimum to maximum is the question. So minimum is parallel combination divided by series combination, you have to get it. There 4:1 is the answer for that. So question is, two identical resistors of 24 ohm each are connected to a battery of 6 volt. Calculate the ratio of the power consumed by the resulting combinations with minimum resistance and maximum resistance. It's a 2024 questions. Do it well, pause the video and practice yourself. Then compare the answers with this. You got it. Let's go to the next question. A 6 ohm resistor, a 12 ohm resistor and a 18 ohm resistor. So 6 ohm, 12 ohm, 18 ohm resistor and a plug key all connected in series. Calculate the flowing when the key is closed. So you have to draw a circuit diagram first of all. So 2 volt cells means there is 12, 6 into 2. So there is a 6 cells individual one, you have to make it. Or as a whole, 12 volt also you can make it. Not necessarily that one, so 12 volt. Positive is here, negative is here. Then 6 ohm, 12 ohm, 18 ohm and a key are connected in series. So to the cells only given. So it is first resistance, then second resistance, then third resistance, then there is a plug key. Key is closed. This is 6 ohm and this is 12 ohm and this is 18 ohm. So from positive to negative, the current will pass through it. The same current passes and concludes the circuit. This is a circuit diagram. For that, you have a mark. So we draw. Now calculate the flowing. You have to calculate electric current flowing through it. Potential difference across 18 ohm resistor. How much is the potential difference? Then electric power consumed in 18 ohm resistance. So to find the current, we should know the total resistance of the circuit. Is it? So part 1, if you answer, current I is equal to V by R. From Ohm's law we have voltage by resistance. Voltage we got 12 volt is the maximum. Then total resistance how much? So I'm using it as RS. So total resistance RS in series they are connected. So that is 6 plus 12 plus 18. 6 plus 12 plus 18. Or the 3 you have to add. So 6 plus 12 is how much? 18 plus 18, that is 36 ohm. That is RS. So this is equal to V is how much? 12 volt is there. So 12 divided by 36, that is 1 divided by 3. So that is 1 by 3 ampere. That is the current. 1 by 3 you can write 0.33 amps. That's current. So total current, that same current will pass through all of them. 1 by 3 ampere it is. You got it. So 12 divided by 36 is 3 into 12 is 36. So 1 divided by 3 ampere is answer. Now, second part if you come. The potential difference across 18 ohm resistor. So 18 ohm resistor, what is the potential difference? That is the second question. So voltage across 18 will be equal to current how much is passing? 1 by 3 ampere is passing through it. So current into resistance, that will be voltage V is equal to I into R is there. So that is I times R of this one. So R 18 you can say, that is 18 ohm only. Same current pass through all of them. So this will be I is how much? 1 divided by 3 into 18. So that is how much? 18 by 3, that is 6 volt will be there. So across 18 ohm, there is 6 volt of potential difference. You got potential difference also, current also you got it. Now, the third part. Electric power consumed in 18 ohm resistor. How much is the power across 18 ohm resistor? For that, power equation you have to use. So for power equations, we have P is equal to, any equation you can say voltage into resistance, current you can put it. So that's easy one. V into I you can use it. V is how much? 6 volt into I how much? 1 by 3 is there, that is 2 watts. So 2 watts is the power across 18 ohm. Then if you go through this 6 ohm, then 6 into 1 by 3. Current is given 1 by 3 only. Then across each one you have to find like that. I square R like that. Hope you got it? Next question, let's see. The potential difference across the two ends of a circuit component is decreased to 1/3 of its initial value. So initially is V, is 1 by 3 is decreased to, while its resistance remains constant. What change will be observed in the current flowing through this edge? Name and state the law which helps to answer this question. So that's a direct question based on Ohm's law. You know the relation between voltage or the potential difference and current. The intensity of current passing through the wire is directly proportional to the potential difference across the ends of the wire, provided the temperature remains constant. So if temperature is constant, resistance also will be constant. So at constant temperature, V is proportional to I. That's the first part. V is proportional to I. So if V is proportional to I, if potential difference is decreased to 1 by 3, then current also will be decreased to 1 by 3. So if V dash is equal to V by 3, initial voltage is V, it's 1 by 3 become. Then new current I dash also will be I by 3. So then statement if you write, as we are getting from Ohm's law. So here see, name is Ohm's law. Then state the law, that's very important. While attending the questions, state the rule to govern, to give the direction of magnetic field across a conductor. Like that questions be done. We'll be doing this one in magnetic effects of current. So there, state means you should write the statement too. After naming it, statement you should write. Many of you, while correcting the papers, we could see that one. Yes, you'll write right hand thumb rule, Fleming's left hand rule, Joule's law of heating. This name you will give. There, if state is mentioned, you should state, give the statement. So here, name and state. Name is what? Ohm's law. What is statement? The potential difference across the ends of a wire is directly proportional to the intensity of current passing through it, provided the temperature like terms or quantities remains constant. So the statement should be given. So this is a symbolic representation actually. Then you have to make the statement properly. Once more, the statement is the potential difference across the ends of a conducting wire is directly proportional to the intensity of current passing through it, provided the temperature like physical quantities are kept constant. Hope you got it. Let's go to the second part of this question. Draw a schematic diagram of a circuit consisting of a battery of 4 1.5 volt cells. So 4 cells are there. Each cell is 1.5 each. So how much will be 1.5 into 4? That is 6 volts. A 5 ohm resistor, a 10 ohm resistor and a 15 ohm resistor and a plug all contained in series. See, it look like similar question we done just now. So the same figure you can make it. What's the figure? 3 resistors are there and connected with plug key, and this is will be 1.5 each, so total will be 6 volt. 1.5 into 4. Then the resistors are 5 ohm, 10 ohm and 15 ohm. Now find the electric current passing through the circuit. Total current will be how much? I you have to find out. We discussed already, the current passing through a series circuit will be same. Now, how much will be it? That I will be equal to V by Rs. In series circuit, how much is there? 5, 10, 15. So net resistance Rs is equal to, we have R1 plus R2 plus R3. That is 5 plus 10 plus 15. That is 30 ohm. That's 30 ohm. In the exam, you should show the steps. How do you got 30 ohm? For that, you will get the marks. Okay. Sometimes our students will do, without showing the steps, you will write the answer directly. If answer is wrong, no marks you will get. But you wrote the steps and you made the mistake. Then for the steps, you make it marks. Half mark like that will be there for each step. Only final answer, half mark will be cut. So please take care. Always write the steps. Don't do the steps in mind work and then writing the answer directly. Never. So here I is equal to V by Rs. V is how much? 6 volt. So that is 6 by 30. Rs is 30. So 6 by 30 is 1 by 5 ampere. 5 into 6 is 30, no? So 1 by 5 amperes are there. I, the current passing through it. Next question. The potential difference across the 10 ohm resistor when the plug key is closed. So across 10 ohm, what is the voltage? V10 you have to find out. Voltage V is equal to I into R. How much is the current passing? I is how much? 1.5 ampere we got. The same 1.5 ampere pass through over 5 ohm, 10 ohm and 15 ohm. So here 1 by 5 ampere current is passing through it. So here about 10 ohm it is. So current will be V will be equal to I into R, that is V is equal to I into R, and I we have 1 by 5 ampere into R is 10, that is 2 volts will be the voltage across 10 ohm resistor. Each one you can find out that 5 ohm resistor will be 1 by 5 into 5, that is 1 volt, like that. Okay, so hope you got it. Here also another 3 mark questions. Do it well. Statement of the Ohm's law there, you have to write in detail about it. Then how to find the net current and this one. So here 3 mark, here 2 marks. So like that 5 mark question it is. 2024 is asked. So please be ready on this chapter. Let's see the next question. When is the potential difference between 2 points said to be 1 volt? So it's actually, what is 1 volt? You know, potential difference is 1 volt. So volt V is equal to work by charge. The amount of work done in bringing or in moving a charge from one end or one point to another point of a wire or conductor is called potential difference. So work done by charge is potential difference. So when it is said as 1 volt, so for that purpose, SI units you have to make it, work should be how much? 1 joule of work. And if charge how much? 1 coulomb of charge. Then V equal to 1 volt. So the potential difference is said to be 1 volt when 1 joule of work is done in moving 1 coulomb of charge from one point to other point. So when is the potential difference between 2 points said to be 1 volt? You got the idea? So it's said to be 1 volt when 1 joule of work is done in moving 1 coulomb of charge from one end to the other point. Is that fine? Okay, let's see the next part. Second part. A copper wire have a diameter of 0.2 millimeter and a resistivity of 1.6 into 10 to the minus 8 ohm meter. So diameter is given and resistivity is given. What will be the length of this wire to make its resistance 14 ohm? To make it resist 14 ohm, what should be the length? That's the question. So for that, we have to use the expression which link resistance, resistivity and length. So we have R is equal to rho into L by A. the basic equation for resistance in terms of resistivity, length and area of cross-section. Here, length L is equal to R into A by rho it is. Resistance into area of cross-section divided by resistivity, rho. So here if we substitute everything, we have R is given how much? 14 ohm. No need to change. It is SI system. Then resistivity is given. Rho is given how much? 1.6 into 10 to the power of negative 8 ohm meter. See, that's also in SI system. No need to convert. Now, we need area of cross-section. For that purpose, diameter is given. So in terms of diameter, we have area of cross-section A is equal to pi into R square is the area of cross-section, or R, instead of R square you can write D square by 4, because we have radius is equal to diameter by 2. That's the logic. Radius is equal to diameter by 2. Hence, area is equal to pi D square by 4. And this is in millimeter. You have to convert to meters. Okay? So let's see the equations. So R is equal to, so here pi is how much? 22 by 7 we can keep it, into D square. D is how much? 0.2 millimeter is there. So it is 0.2 into 10 to the minus 3, the square divided by 4. If we substitute here, R is 14 into A is 22 divided by 7 into 0.2 into 10 raised to minus 3 the whole square divided by 4. So this as it is I am keeping, I am not multiplying separately. So it's easy for you to do it. Then divide by rho. What is rho? 1.6 into 10 to the power of minus 8. So altogether a single multiplication if you do is easy for you to cut short the values. Here see 14 is there, here 7 is there. So if you cancel, become how much? 2 in the numerator is coming. Yes or no? Then that 2 and this 4 you can cancel with what? 2 you can cancel it. So like that you can cancel each other. So here, if you do the cancellation work, this 7 and this 14 if you do, 2 is there, and this 2 and 4 you cancels, 2 is there, and this 2 and 12 you cancels, 11 is there. Is it? So cut short method will be easy for you to do it. Now inside the bracket, 0.2 into 10 raised to minus 3 the whole square. Then you can write 2 times 10 raised to minus 4 the whole square. So 2 square is there, 10 raised to minus 3 the whole square is there. How to do that one? So here, the final answer will be here, like L is equal to, we have numerator 11 is there, into 0.2, I am writing 2 into 10 raised to minus 4. The whole square is there, so 2 times you have to multiply. 2 into 10 raised to minus 4. Divided by the denominator. Is all cancelled, only 1.6 into 10 raised to minus 18 is there. 1.6 into 10 raised to minus 8. So if you do that one, it will be 16 into 10 raised to minus 9, you can keep it. The decimal place towards right if you make it, increase the power. So keep it whole numbers, easily you can divide it. So it will be, here 2 into 2, 4 is there, that 4 and 16 you can cancel. So how much? Denominator 4 will be there. So this is 11 by 4 into 10 raised to minus 4, 10 raised to minus 4 is there, 10 raised to minus 8, then here also 10 raised to minus 9. If you take it in numerator, it will become 10 raised to minus 8 into 10 power of 9. That is 10 power 1 is there, and 11 by 4 will be equal to how much? Nearly 12 by 4 is 3. So it will be 2.8 and almost 2.8 you can keep it as into 10 raised to 1 meters. That is how much? 28 meters will be L. Approximate. So it will be 7 times 7.5. So approximation kind of 2.8. So 28 meters will be the length of that wire. So resistance is given, resistivity is given, and diameter of the wire is given. Then you should have this much length to get that resistance. Pause the video and practice this calculation proper, then you could solve it easily. Never worry about the numericals, but you have to focus more on it. Let's go to the next question. Which type of circuits, series or parallel, be used? So two concepts are there, series or parallel, should be used when you have to operate different electrical gadgets in your house. So different electrical gadgets means they need different amount of current. Then which circuit you will prefer, series or parallel? We know the basics. In series combination, same current passes through all the gadgets, but here different gadgets. And moreover, in series, one more drawback is there. If one gadget got malfunction or non-working, stop work, then nobody can work because the entire circuit stops working. So parallel is better. Though they have same ratings, still parallel, if you can know, each one can be operated separately. So list two reasons for your answers. So which one do you prefer? We refer the parallel circuit. Why it is? One, different current is required. Here, different currents are required. Then they can operated separately. Independently they can be operated. Separate operation can be done. Can separately operated for this. Two reasons. Or you can do, if one stops working still, other circuit can work. These are the reasons you can keep it. That's a benefit of parallel circuit. So only in domestic circuit, we prefer the parallel combination of the devices. Okay, the second part. Find the current flowing through the flowing circuit. What is the total current flowing through it? Here this is given 4.5 volt is the voltage given. 3 ohm is here, 6 ohm, 2 6 ohm in series, then 3 ohm is here. These are the resistances. So here, this 6 and 6 is in series. From the parallel combination you can start with. So this 6 and 6 in series. So how much total you have? Here 12 ohm will be there. You have to add both. That 12 ohm and this 6 ohm in parallel. So you can have, suppose I am making it R1, R2. This is R3 and this is R4. So R2 and R3 in parallel. You get R dash. How much will be? This is 6 ohm and this is 12 ohm. So parallel means 1 by Rp is equal to 1 by R1 plus 1 by R2. If you take the LCM and cross multiply, you will get it is R2 into R3 divided by R2 plus R3. If you do, you will get the answer directly. So it is 6 into 12 by 6 plus 12. 6 plus 12 is how much? 18. And if you cancel it, you will get it is 4 ohm. So R dash is 4 ohm. So here you are getting an effective of this together will be 4 ohm. So 3 ohm, 4 ohm and this 3 ohm are in series. So total resistance here Rs is equal to 3 plus 4 plus 3. That is 3 plus 6 plus 4. That is 10 ohm is the effective resistance Rs. So in this circuit total we have 10 ohm resistance. Now current flowing through. How much is the voltage? 4.5 volt is there. So current I is equal to V by R. So V is how much? 4.5 by R is how much? 10. That is 0.45 amps. So net current passing through this is 0.45 ampere. Total resistance we have to find out. So you have to solve it. Series first be done in the parallel combination 6 and 6 12. That 12 and this 6 in parallel. We got 4 ohm effective. Then 3 ohm and 3 ohm in series. So 3 ohm, 4 ohm and 3 ohm in series. Total 10 ohm we got it. And voltage is 4.5. Hence current is 4.5 by 10. That is 0.4. So answer here in second part. The current I is equal to V by Rs. The total resistance. That is 4.5 divided by 10. 0.45 ampere. Hope it's clear. Let's see the next question. The values of current I flowing in a given resistor for the corresponding values of potential difference V across the resistor are given in the following table. So I and V is given in the table. I and V is given in the table. So it's 0.5, 1, 2, 3, 3.5. Like that, current is changing. Voltage is given 1.5, 3, 6.2, 9.3, 10.8 is given. Now, plot a graph between V and I. So it's regarding relation between voltage and current, the Ohm's law experiment, you can say. One practical question also is arranged. Okay. So if we plot the graph here, voltage across y-axis and current across x-axis we plotted. If the values are plotted here, for 0.5 we have 1.5 volt. So 0.5, this is 0.5 here. Then we have the voltage is 1.5. So it is 2 and almost here. So for 0.5, here is the value. 1.5. It's 2 volt, 4, 6, 8, 10, 12 is there. So while taking the divisions, you have to take utmost care here. Change it from 1.5 to 10.8. So till 12 volt or 11 volt like that you have to need that. Yes, okay. So 0.5, 1 volt, 1 ampere. We have 3 volts. So 1, we have 3 here. The middle of this one, 2 to 4. Then we have 2, we have 6.2. So for 2 ampere, we have 6, almost 6.2. So here is the value. Then we have 3 ampere, we have 9.3. 3 ampere, we have 9.3. So 9 is, this is 10, half of this almost we can do, 9.3. Then for 3.5, we have 10.8. So 3.5 is here. This is 10.8, almost 11 it is. So I'm keeping. This is the points. Now join these points. If you join this one, it will be like see, we got the VI relation graph. So almost it's a straight line only. All the points are coming on the straight line. So on the graph sheet, if you do in the time of exam, if it's for asking, then or plot with scale and pencil in neat way. Have you got it? See the part of this. So plot the graph between V and I. Now calculate the resistance of the resistor with the help of this graph. From the graph, you have to find the resistance. So from VI graph, the best application is you can calculate the resistance. The slope or gradient of the graph gives you the resistance. So we can calculate the resistance of this value. See here, you take any 2 points from this graph. Any 2 points you can take it. So for example, I am taking this point and this 0 point I am taking for easy calculations. So here, this point is taken as x1, this point is taken as x2. Same thing, y1 here and corresponding, this one as y2 you are taking. So slope you have to calculate, slope is equal to y2 minus y1 divided by x2 minus x1. y2 minus y1 by x2. The y coordinate divided by x coordinate. y2 is how much? 6 minus 0 is a, so this is equal to 6 minus 0 divided by x2 minus x1. x2 is how much? 2 is there. 2 minus 0, almost there. So that is actually 6.2 it is, minus 2 minus 0 is there. So 6.2 by 2, 6.2 by 2, that is 3.1 ohm is the value. So resistance is 3.1 ohm, the approximate value. The average resistance is 3.1 ohm. Slope is y coordinate by x coordinate. So if you divide it, you get 3.1 ohm. Now, the third part, what does the graph represent? So the graph represents that voltage is directly proportional to current and the conductor obeys Ohm's law. So it obeys the Ohm's law. It obeys Ohm's law. Why? It's a straight line curve between voltage and I, because V is proportional to I, as the Ohm's law says. Now, one more part is the third part. Why should this graph pass through the origin? So, it's passed through the origin because it's exactly obeys Ohm's law, and when voltage is zero, current should be zero. Hence, it should pass through the origin. If there is no voltage potential difference, then current also will not be there. So, V is 0. If V equal to 0, then I also equal to 0. Hence, the straight line passes through the origin. Hope you got it? Let's see the next question. Write the relation between resistivity and resistance for a uniform metallic conductor of length L, area of cross-section A. Use these relations to obtain the SI unit of resistivity. We've done already the same part. In another region, this question came, so only that part is repeated. We've done already. Resistivity rho is equal to R into A divided by length L. That equation we know. Because resistance is directly proportional to length and inversely proportional to area of cross-section. From there, we get that constant of proportionality. You have to find the SI unit there. So, SI unit of rho is ohm meter it is. How? R resistance half the ohm into area half meter square by length half meter. So, if you cancel 1 meter square and meter, is given ohm meter. So, that is ohm meter. You got it. Now, come to the second part. As new. The resistance of a metallic wire of 100 meter is 20 ohm. If the radius of the wire is 5 millimeter, find the resistivity of the material. Rho you have to find out. So, numerical values are different. A similar question be done here. So, if you do that part, then here we have length is given 100 meters. Resistance is given 20 ohm. And radius of this wire is given 5 millimeter. So, that is 5 into 10 raised to minus 3 meters. Resistance is given. See the values. Now, you have to find the resistivity. So, resistivity rho is equal to R into A divided by L. So, what is R? 20 into A, that is pi R square. So, A is equal to pi R square is equal to 22 by 7 into R is how much? 5 into 10 raised to minus 3 the whole square. So, it will be 22 by 7 into 5 into 10 raised to minus 3 into 5 into 10 raised to minus 3. Divided by L. What is length? Length is given how much? 100 meter is given into 100. So, what is the symbol? So, if you calculate it, you can do the idea like this way. This 20 and 100 you can cancel. How much will be there? It can be 5 here. So, this 5 and 1 5 cancel. Then 22 by 7 into 5. That's the last part. So, it will be equal to 10 raised to minus 3 and 10 raised to minus 3 is 10 raised to minus 6 is there. So, 10 raised to minus 6 into 22 by 7 is 3.14, you know. So, 3.14 into 5. It will be 3.14 into 5. You will get 0, 2 is there, 1 to 5 is 7 is there, then 3 into 5, 15 is there. So, it will be 2 decimal places there, 15.7. So, 15.7 into 10 raised to minus 6 or this equal to that much ohm meters you can write. The standard way of writing it is 1.57 into 10 raised to minus 5 ohm meter. You got it? So, let's go to the next question. Obtain an expression for the amount of heat produced in a conductor of resistance R when a steady current I flows through it for a time t. So, you have to obtain an expression for it. It's actually Joule's law of heating, you know. When heat produced by the passage of current through a conductor is directly proportional to square of the intensity of current resistance and time of the flow. So you have to obtain that relation. In a pure resistive circuit, the electrical energy passing through it is completely converted to heat energy. So the energy produced in a resistance is heat energy. So the value of energy is equal to heat produced. For that relation, we have energy is equal to power into time. Energy is equal to power into time. Now, what is power? Power is, we have V into I into T. Since power is equal to V into I. Now, from Ohm's law, we have V is equal to I into R. So, if you substitute it, it is I into R into I into T. That is I square R into T. This energy, so I is square into R into T, that is equal to heat energy. So, H is equal to I square into R into T. For this entire question, we have 3 marks. So, this part will have the first section of the mark. It's equal to I square RT. Now, if it is for 3 marks, then you can calculate this power also equation. So, the work done, if you do it, work done, we can have voltage into charge. So, work done by time will be the power, then power into time you can use it. Have you got it? Okay. Now, next part. An electrical heater of resistance 10 draws a steady current of 5 ampere from the service mains for 2 hours. Find the power of this heater and the amount of energy consumed in kilowatt hour. So, power and energy you have to find out. So, for that purpose, we have power is equal to I square into R. That equation you can use it. Because here current is given and resistance is given. So, I squared R is equal to what? I is 5. So, 5 square into R is how much? 10. 5 square is 25 into 10 is 250 watts. Then, the amount of energy consumed by a heater in kilowatt hour. So, this is given 2 hours. With this power, how much energy will be consumed? So, for energy, we have the equation E is equal to power into time. So, in kilowatt hour, so power 250, you have to convert to kilowatt. So, it will be equal to 250 divided by 1000 into hour is given 2 there. So, it will be 250 divided by 1000 is 0.25. Is it? 00. So, 0.25 into 2. 0.25 into 2 is how much will be? 0.5 kilowatt hour. 0.5 kilowatt hour is the answer for the total energy consumed by this device. The next question is, when electric current flows in a purely resistive circuit, electrical energy gets fully converted into heat energy. See that statement we told just before. So, whenever purely resistive circuit, if current passes through it, that electrical energy is converted to heat energy. The amount of heat produced in the circuit is found to be directly proportional to the square of current I square, the resistance R of the conductor, the time T for which current flows. In other words, H equals I square RT. See, that's a statement of Joule's law of heating. Electrical devices such as electric fuse is a device, electric fuse, electric heater, electric iron, etc. are all based on this effect called heating effect of electric current. So, it's a statement is given, just like a case-based study course is like. Okay. A. List 2 properties of heating elements. You have to write 2 properties of heating elements. And list 2 properties of electric fuse. So, in compared to heating elements, what is electric fuse also should be. So, like that 2 concepts. Okay. Heating elements have to convert electrical energy to heat energy. And we should get sufficient amount of heat required. Suppose electric iron, while we be using it, we need sufficient amount of heat energy to cloth. So to produce that one, more amount of heat should be produced. So it should have high resistance. And at high temperature also, it should continue to give that heat. So it should not melt. Solids, if heated after a limit, it melt. So melting point of heating devices should be very high. They should be ductile, we say, because they are formed in the form of coils, thin coils. If area of cross section decreases, the resistance increases, So two ways. Already the resistivity is higher, and if the wires are made to thin wires, then again resistance increases. So high resistance. One quality, high resistivity. Another quality, the melting point also high. So they should not melt easily. The melting point should be higher. So this all should be high for a heating device. Got it? Now for B, list two properties of electric fuse. So electric fuse also working on the principle of heating effect of electricity. Electric fuse is a safety device in the electric circuits. Whenever the current than their rating flows through the circuit, the devices or the appliances may get damaged. So in order to protect them, the electric fuse is used. So fuse melts when more amount of heat passes through it. So it should melt easily in compared to other heating devices. So for that purpose, electric fuse should have high resistance, of course. Solely proper heat will be produced, but it should have low melting point. That's very important. Heating devices have high melting point, it should not melt. But electric fuse should melt if more amount of current passes through it. So high resistance and low melting point are key points for electric fuse. Hope you got the answer. It's a 2024 question, one of the region key. Let's go to the next question. Name the principle on which electric fuse works. Explain how a fuse wire is capable of saving electrical appliances from getting damaged due to accidentally produced high currents. See the same thing, another region the question came, so it's better. So what is the principle? Heating effect of electrical current or electrical energy. When current passes through a conducting wire, heat is produced. It is proportional to resistance and square of the current passing through it and the time. Hence, more current passes through, more heat is produced and it melts. So you have a low melting point. Hence, no current will pass through the device. So the same explanation you can write here. Let's move to the next question. The power of an electric heater is 1100 watts. 1100 watts. If the potential difference between the terminals of the heater is 220 volts, find the current flowing in the circuit. You have to find the current. What will happen to an electric fuse of rating 5 ampere connected in this circuit? So you have to calculate the current passing through it. We have power P is equal to V into I. So current I is equal to P by V. Few of the students used to face difficulty in transforming the equations. For them, they can remember this concept by a triangle making the relation of P, V and I. So P on the top, V and I on the bottom. P is equal to V into I, or I is equal to P by V. You know how to use this triangle. I is equal to P by V. V is equal to P by I. P is equal to V into I. That way if you make it, transformation problem won't be there. Sometimes in the paper we used to see that mistakes. Instead of P by V, they used to write V by P. So don't make that mistake, answer will be wrong. And if it is MCQs, you could see the answer of V by P also will be there in the options. So it will give you wrong answers. So P by V, I is equal to, what is P here? Is given 1100 watts divided by, what is V here? 220 volts. So it's equal to 100, you cancel this. 11 by 22 is 2. So it is 10 by 2, that is 5 ampere. So here 1100 by 220, that is 5. So 5 ampere is the answer. You got it? Now, it's given if what will happen to an electric fuse of rating 5 ampere connected in this circuit. So 5 ampere rating fuse is connected. So fuse maximum current allowed will be 5 ampere. So 5 ampere it can pass through. But normally if the device needs 5 ampere current, then the fuse selected should be little bit higher rating. More than 5 should be selected. Then only the device can work. That is what happened now. So after increasing the just a point fluctuation is there, the fuse will melt and the circuit stop working. So if it is 5 ampere, then like 7 ampere or like that, just higher value of the ratings we normally used to select. So if 5 ampere itself the fuse connected, then little bit of fluctuation will make the fuse to melt and the device will stop working frequently. That's the outcome will be. So let's go to the next question. In a domestic circuit, 5 LED bulbs are arranged as shown. The source voltage is 220 volts and the power rating of each bulb is marked in the circuit. Based on the following circuit diagram, answer the following questions. So few questions are set. Then we have to solve it one by one. Okay. So here is a circuit there. The circuit is of 220 volts is given. Okay. And ammeter is there. Then we have 1, 2, 3, 4, 5 bulbs are there. This way they are connected. 2 keys are there, K1 and K2. Question is, state what happens when key K1 is closed. Only K1 is closed here, suppose. Then see, from the battery, the current will pass through it and through the bulb, then complete the circuit. So only which bulb will go? This bulb A will glow here. Bulb A will glow. You got it? So his power is given 222 watts and 220 volts it is. Okay? So 220 volts is a voltage there, 22 watts is the power. So it will glow. Only A. B, C, D, E will not because that circuit is open. Now, key K2 is closed. So only key K2 is closed. Then this bulb A will not be, but B, C, D, E will glow it. So all of them off. Okay. See, one more thing you have to consider. They are in 55 watts are there. So 55 volts plus 55 volt. 110 plus 102. So total voltage is 220 volts only. So all of them can work. Potential difference will be different, you know. In series, it's the same current pass through it, so they could work again. You got it? So that's the two concepts here. Then, next question is, okay, find the current drawn by the bulb B when it glows. You have to find the current through bulb B. So bulb B, we have this one. Its volt is 11 volt and voltage is 55 volt. So current through that one we have to find out. So current I is equal to what? P by V is it? So it's given clearly power is 11 and voltage is 55 volt is given. So the current I is equal to power by voltage. So that is power is 11 watts and voltage is 55. So 11 by 55. That is 1 by 5 ampere. That is 0.2 amps. 1 by 5 it is. How we got it? So, see, calculate the resistance of the bulb B and the total resistance of the combination of 4 bulbs B, C, D and E. Resistance of the bulb B also asking. So power and voltage is given there. So resistance R is equal to, we have power P equation. One more equation we have for power, you know. P is equal to V square by R. It gives that R is equal to V square by P. R is equal to V square by P will be there. So if you do, this will be, V is how much? 55. So 55 into 55 by P. Power is how much? 11 is there. So its resistance will be equal to 55 by 11 is 5. 5 into 55, that is 275. That much ohm is the resistance of that bulb B. Now, you would ask, total resistance of the combination of 4 bulbs, how much will be? B, C, D and E is there. So here we have B is 11 watts, 55 volts, 11 watts, 55 volts. All of them are same values. Is it? And B have this much. Then the net will be, they are contained series. So total resistance, how much will be? That we have to find out of these 4 bulbs together. Since all these bulbs have same resistance, 275 ohm each, the net resistance we have to find out in the second part. So that part will be net resistance Rs is equal to Rb plus Rc plus Rd plus Re. That is 4 into 275. That is nothing but 1100 ohm. Total is 1100 ohms. Got it? So then you can do this way also. This is total. Current is 0.2 ampere we have. Then net power we know. Then reverse it. Is the concept. Okay? Now see, one more question is there. See, what would happen to the glow of all the bulbs in the circuit when keys K1 and K2 both are closed and the bulb C suddenly get fused? Give reason to your answer. Justify your answer. So C is fused. Then what happens, K2 is closed, So K2 is closed and C is fused means this circuit nobody will work. Only who will glow? Bulb A only will glow then. Because there is only the circuit is closed one. So only A will glow. Because no current passes through the second part. Because C is fused. Hope you got it? Let's move to the next question. Study the following circuit. So in the circuit, 6 volt battery is there, 4 ohm, 6 ohm, 16 ohm. Then 2 8 ohms in parallel and all together they are contained in series. On the basis of this circuit, answer the following questions. The first question is, find the value of total resistance between the points A and B. So here see, this is A and this is B. Between A and B, what is the total resistance? So there are 3 resistors, 4, 6 and 16. All of them are contained in series. So between A and B, just what to do? The resistance RAB is equal to, all are in series. So what to do? Add all together. So 4 plus 6, 10, 10 plus 16, that is 26 ohm. Direct question, 1 mark will get. B part, find the resistance between the point B and C. So it is B, it is C. Between B and C, there are 2 resistors, 8 ohms in parallel. So RBC will be 2 are there in parallel. So 1 by 8 plus 1 by 8. That is 2 by 8. That's 1 by 4. That is 1 by RP. Then RP will be this one. So you can do R by 2. That is 4 ohm. 8 by 2, 4 ohm. Because parallel resistors 8 and 8 are there, we have the shortcuts. RP is equal to, you can use R by N. If all the values of same resistors, then R by N will be the net resistance. Next one, C part. Calculate the current drawn from the battery when the key is closed. So when key is closed, what is the total current passing through? So total between A and C, what is the resistance will be? Between A and B, we got 26 ohm. B and C, we got 4 ohm. 26 plus 4, how much? 30 ohm. So net resistance here will be equal to 30 ohm. And voltage is given, how much? 6 volt. Then current I is equal to V by R. From Ohm's law we can have it. That is 6 by 30. 6 by 30 is 1 by 5 ampere. That is 0.2 ampere. So net current will be here 0.2 ampere. Simple direct questions are there. Then C part, again 2. In the above circuit, the 16 ohm resistor or the parallel combination of 2 resistors of 8 ohm, which one of the two will have more potential difference across its two ends? Justify your answer. So which you have more potential difference is asking. So potential difference, we know the equation V is equal to I into R. All of them all together in series, they are connected. So I is same. How much? 0.2 ampere. Now across 16 ohm, V will be 0.2 into 16. That's how much? 16 into 2 is 32, and that is 3.2 volt. So here it is 3.2 volt we have across 16 ohm. So in this equation of V16 is 3.2 volt. Now across these two, both are total how much? 8 by 4 ohm is there. We have 4 into 0.2. It is how much is 0.8 volt total is there here. Because total resistance is 4 ohm only. So across 4, I is passing through. Is it? So total current is 0.2 ampere only. So net voltage across is 0.8. So both will have 0.8 each, the voltage. You got it? So V8 will be 0.8 volts. So which have more potential difference? Of course 16 ohm off, because it have more resistance. So more resistance, more potential difference will be there. As from Ohm's law we have V equal to I into R. Is that clear? Let's move to next question. VI graph for two conducting wires A and B are shown. If both wires are of the same length, they have same length and they have same diameter, which of the two is made of a material of high resistivity? Same length is there and same diameter also there, then the one which have greater resistivity will have greater resistance, because we have the equation R is equal to rho into L by A. L and A is same for both, then R is proportional to resistivity. As the resistivity increases, R also increases. Now give reason. So from the graph, it is voltage is taken along x-axis and current is taken along y-axis. So VI graph, it is the slope of the VI graph gives you the resistance. If you find the slope, then here B have more slope in compared to this one. Or the line which is more inclined to V, voltage axis, will have more slope always. So here resistance of B is greater than resistance of A. If resistance is greater, resistivity also greater only, of course. So here, because both have same length and diameter, then which one of these made up of a material having high resistivity? So which one? B is made up of high resistivity. So the resistivity of B is greater than the resistivity of A. That's a justification. So VI graph, if it is given, then they ask for which have higher resistance. Then always keep in mind the line which is more inclined towards voltage axis. The line which is more inclined towards voltage axis have greater resistance. Suppose it is IV graph, current along y-axis, voltage along x-axis taken. Then the line there also towards voltage axis have greater resistance. Their slope will be lesser. Inversely proportional to resistance will be the slope, because IV graph it is. Is that clear? Pause the video and practice it well. Let's move to the next question. Let the resistance of an electrical device remain constant, while the potential difference across the two ends decreases to 1/4 of its initial value. So R is kept constant and voltage is decreases to 1/4. See a similar question we done previous also. What change will occur in the current through it? State the law and help us in solving the above stated question. So which law is there? Sure, voltage and current relation. We have one law, Ohm's law. So Ohm's law is the name. Then you have to state it. Ohm's law statement is what? The potential difference across the ends of a conducting wire is directly proportional to intensity of current passing through the wire, provided the temperature like quantities are kept constant. Here, voltage is become 1/4 of initial value. So we have voltage is proportional to current. So if V dash is V by 4, 1/4 of the original value, then the new current I dash also will be I by 4. If resistance is not changed, so resistance is kept constant, then current also will be 1 by 4th. More the voltage, more the current. Less the voltage, lesser the current will be. As Ohm's law what says. So it's a 2023 question. Take care about this concept of Ohm's law. So state is asked, so you should give the statement also. Please remember, not only naming, you have to write the statement, complete statement you have to make it for the Ohm's law. Is that okay? Next question, let's see. 3 resistors of 6 ohm, 4 ohm and 4 ohm are connected together so that the total resistance is 8 ohm. So total resistance is 8 ohm you are getting. Draw a diagram to show this arrangement and give reason to justify your answer. So 3 resistors are given. How much are there? R1 is equal to 6 ohm, R2 is equal to 4 ohm, R3 is equal to 4 ohm. Now the resultant resistance is given how much? 8 ohm. So if all of them are connected in series, what will be it? We know Rs is equal to R1 plus R2 plus R3. What do you get? 6 plus 4 plus 4. 6 plus 4 is 10 plus 4, that is 14 ohm we'll get. But how much we have to get? We have to get 8 ohm only. So all together if we connect in series, it's not working. So 2 in series, 1 parallel, or 2 in parallel, 1 in series. So let's try one. So this is a trial and error method only. You have to try all the combinations. So sometime if you are strong on numericals, by seeing the values you could predict the answer. 8 ohm we need. Okay. So we have 6 ohm, then 2 4 ohms are there. If 2 4 ohms you connect in parallel, what will be the effective value? 2 ohm. Is it? 4 by 2, that is 2 ohm. So 2 plus 6, 8 ohm we can have. So we can have a trial like a 6 ohm here, then that's connected to 2 4 ohms in parallel. So this is 4 ohm and this also 4 ohm. Now other way also you can check it. 6 and 4 in parallel, then that other 4 in series like that. So you won't get this same answers. 6 and 4 in parallel, you will get 6 into 4 by 6 plus 4. So it will be more than 8. Okay. So here will be the answer. 4 and 4 is there. So that B, here we will get 2 ohm as the effective value. So 6 plus 2 will be how much? 8 ohm will be the R dash. Total in series comes, it's 8 ohm. So here if you do, in normal calculation you do 1 by Rp is equal to 1 by R1 plus 1 by R2 here. So it is, R2 and R3 you gave the name. So it is 1 by 4 plus 1 by 4. That is 2 by 4. That is 1 by 2. That is 1 by Rp. So Rp is equal to 2 ohm. It's shortcut. What is the shortcut? If we have same values of resistors, similar resistors connected in parallel, then Rp is equal to R by N. So 4 ohm is R by N is 2. Number 2. So 4 by 2 is 2 ohm. Rp is 2 ohm. That 2 and this 6 in series. So total is 6 plus 2, 8 ohm. So this is the circuit diagram we can say. Justification by showing the calculation, you could do it. Have you got it? So this type of question is trial and error we call it as. You have to check all the combinations which give you the proper answer. So by seeing the numericals sometime, you could predict this maybe. So that try. If not, then go for the other method like other diagrams and then confirm the answer. Have you got it? Next question is, an electric iron consumes energy at a rate of 880 watts when heating is at the maximum rate and 330 watts when the heating is at the minimum. If the source voltage is 220 volts, calculate the current and resistance in each cases. So 2 cases are given. Current and resistance you have to calculate. Current and resistance in each cases. So power is given and voltage is given. So you have to find current and resistance. We have the equation as power P is equal to I square into R, one idea, and power P is equal to V square by R, another idea. From here you can find, and power P is equal to V into I also, one idea, sir. So first case is you have to find the current. So the power and voltage is given. So out of this, voltage and power current, this is the relation. So here I is equal to power by V. What is power by V? Power is how much? 330 watts in maximum and 880 watts. So two cases are there. Maximum rate 880 watts. So maximum I max is 880 divided by voltage is how much? 220 in both cases. So it will be 4 ampere. Maximum is 4 ampere. Now I minimum will be, how much is the cases? 330 watts. 330 watts divided by, what is the voltage? Same thing only, 220. That is, if you do it, 0, 0 cancels. 33 by 22 is there. That is 3 by 2. That will be equal to 1.5 ampere. 1.5 ampere we are getting. So 33 and 12, 22. With 11 you can cancel. So that is 3 by 2. That's 1.5 ampere. Maximum and minimum current you got it. Now, in both cases, what is the resistance you have to find out? So for resistance, we can use this equation. R is equal to V square by P. Rewrite this equation, V square by P. Or you can use this equation also, P by I square. So I is, we have, let's square it and do. Both cases you can use it. So it will be like, which is AC that you can use it. So R max will be equal to V by I max if you use it. V is how much? 220 divided by maximum current is how much? It is 4. That is equal to 55 ohm is the resistance. Maximum. Then R minimum if you do it. R minimum is equal to V by I minimum. How much it is? 220 by 1.5. That's almost equal to 146.7 ohm. These are the values of maximum and minimum. So my dears, here all power, voltage, resistance, current, these all relations is very important. So repeated questions we are getting in all the regions. Here we discussed a lot of numerical type questions. Some were for 3 marks. Some questions was there for 5 marks and all. Dears, please pause the video and practice your answer. Make it thorough the concepts. Practicing these questions will help you to face exam bravely. Wish you all the best for the upcoming exam. Prepare well. Send your doubts and clarifications. Stay tuned. See you in another video lesson. Thank you for watching.